Hey people, welcome back. And now we are going to run about the randomness of the data. So why we check the randomness? We are trying to find out, is there any special cause of variation or not in my data? That special cause of variation can be because of 4 specific properties present in your data, which we call as a mixture, oscillation, cluster, and trend. In case any of these specific property present in your data, that is called as a non-random data. So to check the randomness of the data, we run the run chart in Minitab, and run chart will give you the p-value of all of these 4 properties. So data is completely random when the p-value of mixture, oscillation, cluster, and trend, all 4 are greater than 0.05. And data will not be random, which means data is influenced by any of these 4 properties. Either there is a mixture present in data significantly, or oscillation, or cluster, or trend, when the p-value will be less than or equal to 0.05. So if the p-value of your run chart, all of these 4 properties is greater than 0.05, then it's a random data. And if the p-value is less than equal to 0.05, then it's a non-random data. Now let us understand what is the mixture, oscillation, cluster, or trend. So suppose last session we have learned about the normality test. So in this case, first we check the normality of the data. And the data is normal. If the normality test of your data and data was a normal data, then we plot the subgroup around the mean. And if your data is not normal, then we plot the subgroup around the median. I will show you both in Minitab soon. So let's check what is the mixture. So mixture of the data is, suppose this is your mean line or the median line of the data, and you have collected some data point, maybe like this star, and data is mixed from the 2 different populations. Suppose one person of your team is doing on an average 15 transactions, where your process target is on an average they should do at least 10 transactions. And the second person is consistently doing, like in this case, is doing the 5 transaction, and second one is 15 transaction, like this. So you are expecting 10 transaction per person per day, and average 10 you are meeting. So in this case, there is a mixture present in the data. So that's the reason it's not average measurement of the process is not always good. We should see what is the shift in the data, what is the variability in the data as well. So when the data comes from the completely 2 different population, one population, the person who is doing 15 transaction, another population, the person is doing 5 transaction, average it's making 10. This kind of data is present in your process, then it's a mixture present in your data. Oscillation. Oscillation is when your data is making a waves like this. Up and down is happening continuously. So the data points like this is here, like this data points are coming, and now this data start going up. So these kind of waves, if continue, and these waves are significant in the data, then there is a oscillation present. And if oscillation present, the p-value will be less than or equal to 0.05. Cluster, as the name says cluster, data comes in the group. Maybe one group of the data is here. Maybe another group of the data is coming, suppose here. Maybe the another group of data is like this. They are here. So when the data comes in a specific group, data is making a cluster, then it's a cluster present. If the data points are significantly in one group, or data is making a significantly group, across the data distribution, then this is a cluster percent. Trend, when you have the data values are continuously going up and down in a series, maybe 7 or more than 7, so then we will call there is a trend present. So you will see this trend is going downward trend you have in data. Or in case there is a trend which is going upward like this, so then again this is a specific trend present in the data, and because of the trend there is an special cause. And our objective is to investigate why there is a mixture, oscillation, cluster, or trend present in your data, why it is leading to a special cause of variation, fix it permanently, and then run the process. This is what. So run chart is a very powerful technique to identify any special cause of variation or non-random variation. And the randomness of the data we use run chart, and we look at the p-value. If the p-value are greater than 0.05, then data is completely non-random, completely random. There is no special cause. And if the p-value is less than or equal to 0.05, then data is not random. There is a special cause of variation. Let's see how do we do this in the Minitab. So suppose here I have some data. Let me see in the Minitab. And I have this data here. I wanted to check the randomness. Maybe first I will check the randomness of the exponential data. We'll go to the stat. We'll go to the quality tools, select the run chart here. Run chart we use to check the randomness. Click OK. Select your data. Because my data was normal, so I am selecting here, plot the subgroup size around the mean. This is the option, mean I will be selecting. If data is not normal, then ideally I should be selecting the median here. So mean I have selected, I clicked on OK, and here is a graph in front of me. And if I look at the p-values in this graph, the p-value for the mixture, oscillation, cluster, and the trend, all the 4 p-values are greater than 0.05. None of the p-value is less than 0.05, which means this data set is completely random. There is no special cause of variation in this data set. Now, maybe I have another data set. Let's see what this data turned out to be. Go to Stat, Quality Tools, Run Chart, and select your exponential data. Because this data is not normal, so ideally I should plot the data subgroup around the median, ideal condition. Click on OK. And here I look for this data, and I found is still my none of the p-value, either you talk mixture, oscillation, cluster, or trend, all the 4 p-values are greater than 0.05. So this data is also as a it's a random data. Suppose this particular value is, there is a suddenly shoot up in this value, and then it's a increasing order. So this observation number 15, median is 0.27, and observation number 17 is 0.27. So if I make the observation number 16 as well, nearly 0.27, so probably it will show you the trend. Let's see observation number, what is 16. So I go to observation number 16, and this is 0.27197, 0.2703. So I will be making this, let's say 0.27199, and this value 0.27, maybe 201. Yep. And now I will again run the run chart here in this data, because I try to arrange the data in a trend order, if that works. And you can clearly see now the p-value of the trend has come down to less than 0.05. And at this particular point, data is showing a specific trend, which is the continuously in a increasing order or something. That's how the p-value is less than 0.05. This is what the way we identify the special cause of variation with respect to mixture, oscillation, cluster, or trend in any set of data with the help of run chart. Thank you so much, people. I'll see you in the next session.